So we'll finish up talking about law of cosines today. Alrighty, and I'll rewrite the formula here. So to summarize kind of some things we talked about yesterday, for law of sines, okay, you're looking at triangles that are angle, side, angle, 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 side, and also side, side, angle, too. Okay, so when you run across a triangle with this information, okay, that's indicating law of sines. Okay, so if you have an angle and a side and an angle, so the sides between the two angles, you can use law of sines. Angle, angle, side, law of sines. Side, side, angle, law of sines. Okay, law of cosines covers the rest of our scenarios. Okay, so that would be the side, 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 or the we saw it yesterday. Or it covers the angle, side, angle, side, sorry. Side, angle, side. There you go. Okay, so this is what we're going to be looking at today, a side, angle, side problem. Okay. For law of cosines, remember our formulas, the one I'll be giving you for your optional quiz, should you decide to take it, and then also for the mandatory test, I'll give you this formulation of it. Okay. So the leading letter, C, right, it also ends up at the end as the angle, C as well. And then you have the AB and the 2AB kind of thing. Okay, so you can then easily come up with the other, derivations by just kind of moving around some of the letters. Derivations. I think that's an appropriate use of that word there. Okay, thus. Okay. So let's finish up here talking about side, angle, side. We'll do one of those, and then I have like two, I guess like word problem kind of problems we can do. We'll do one together, and then I'll have you guys give you guys one for yourself. There could be word problems on the quiz. Yeah. Okay. And also, well, I'll talk about that one. I'll cross that bridge when we get there. All right. So let's do a triangle here. All right. So. Solve triangle ABC. All right, and we'll draw a picture here. Okay, and we'll say this is A, this is B, and this is C. We'll say A has an angle of 45 degrees. Okay, we'll say that side C is 19, and we'll see that side B is 46. Okay. Now, of course, again, I said we're finishing up law of cosines. I kind of told you here that this is like, give me a law of cosines problem. But let's say you tried to do law of sines here. You would immediately run into a problem because
there's nothing for the 45.
We don't have an angle and opposite side pair that we know. So we know angle A, but we don't know side A. We know side C, we don't know angle C. We know side B, but we don't know angle B. And so there's no pair that we can use to set up our law of sines and solve here. Okay, so we have to use law of cosines here. Okay, and as a result, it's also important to kind of realize here what is going to be the next piece of information that we solve for here.
A. Little a.
So side A, yes, we're going to use side A here because side A, right? We've got, what do we have? We have side B, side C, and angle A. So which of these formulations here have both angle A, side C, and side B? Well, that would be this formulation right here, right? And we're going to solve then for that A squared. So let's set it up, right? We're going to have A squared, that's what we're solving for, equals, okay, 19, well, actually I should do 46, I guess. 46 squared plus 19 squared. I'll get to that. Hang on. Let me just write it out here. 2 times 46 times 19 cosine of, and then 45 degrees there. Okay. So there's our setup. I'm sorry, my 46 there is like really hurting. But there it is. Okay. So we're just plugging in B squared, C squared, and then 2B, or minus 2BC, cosine 45. And again, I would strongly encourage you, be careful how you simplify here. For whatever reason, I guess because they're like numbers, students are really tempted, and students often do, try and just combine all the numbers together and put it in front of cosine. Okay, and typically, then when you try and solve, you end up getting an error or something like that. Well, not in this case, I guess you wouldn't. Well, you might get a negative number. Okay, so if you run across like a weird scenario where like you're doing inverse sine of both sides and you end up with like the calculator giving you an error, or you end up taking the square root of a negative number here, okay, you made a mistake. All right, you made a mistake. All right, and how you're solving. So that's at least can help you diagnose what your problem is, but then you got to find where you made your error, right? So anyway, let's simplify here. And again, I would recommend if you find yourself making errors that you just take more steps, so I'm going to do that here too. So 361, and then 2 times 46 times 19.
Is it supposed to be a big number?
Well, let's wait here and see. I'm not sure myself. Okay. So then I multiply everything out, square everything, and multiply everything. Okay. And so, actually, I mean, if you really want to, because this is all just one big expression here on the right-hand side, you could type this whole mess in your calculator all at once. And then, and get yourself the answer there. So I might just go ahead and do that. So I'm going to combine everything together there. So the 2116 plus the 361 minus the 1748 cosine of 45. Okay. Now, we actually could simplify cosine of 45, right? We know what cosine of 45 is, right? It's
Cosine of 45? It's
root 2 over 2, right? So we could have done that one mentally, right? Yeah. So anyway, we'll put it into our calculators. And there it is, 1,240. Okay.
supposed to be that big. But don't we
Well, are we done yet?
Oh no, we gotta square root it. That's right. Should we round?
So I would not. What I would suggest you do, once you get this number, then just press second square root and then do the answer command, like that. Second negative sign allows us to reuse that. Or again, if you have the newer calculators, you can just go up to the actual quantity there and it just pastes it, copy pastes it. And there it is. Okay, so 35.228 we'll say is our A value. Okay. Of course, we are in an equation setting, so a plus or minus, would potentially work here. But of course, we don't want to talk about a negative side length for a triangle. So in context, we only want the positive value here. We only want positive values. All right, we've got our side A. 35.228. Okay, like so. And now, right, at this point, what do we use to get the rest of the pieces? Law of sines. Okay, law of sines. I would encourage you again to kind of start with the biggest side. So I would go then now to solve for angle B. I think that's a good way to go there. So let's do that. So we'll say sine of B over 46. Okay, 35.228. Cross multiply and solve here. Oops. Okay. And then, of course, we'll do the sine inverse as well there. So. Okay. And then do we need to use law of sines to find angle C? No, just subtract from 180, right? Make it easy on yourself. Okay, don't do more work than you need to. Could you? Yeah, you could. But let's just subtract from 180. 67.583 is what I get there. Did I do that math right? Let's see. Sine inverse. Okay. Yeah, that is weird, isn't it?
Oh no.
There's some sort of weirdness here. So yeah, there is a weird problem here, isn't there? Because of the way that we saw. Well, let me try. Let's try this here. 67.417, 180 minus. Ah, okay. Yeah. So in this case, the angle 112.533 is the one that actually is supposed to work here, not this one. Now, I told you guys that the problems that I'm going to give you will not require this, but this example actually does require it. So forgiveness, please, here. The actual angle B is supposed to be the supplement angle, the 112.583 degrees. Okay. But again, the problems that I give you will not require this, but it's, yeah. And what clues us in here, right? What clues us in, or what clued me in, and Rohan, I don't know if that, what's this, I mean, what clued you in here, Rohan? The fact that had our angles were messed up.
I mean, the fact that side C was smaller than 46 and the angle was larger.
Yeah, exactly right. Okay, so you can see here, right, the issue is that we are going to have a greater angle, not, the greater angle here, 67.583, not by much greater, but still greater, opposite a smaller side than, the 46 there. So in fact, we had to use the supplement. Okay, and then if I do 180 minus the 45 minus the 112.583, we get then 22.417, which makes more sense there.
So since the side for angle C was bigger than angle B, that's
What clues you in? What clued me in? Yeah. Mm-hmm. The idea is that when you are talking about triangles, right, the biggest angle is always opposite the biggest side. Smallest angle is always the smallest side, and then the just right angle is always opposite the just right side. Right, Goldilocks. Anyway, so don't worry about that though. That's not something you'll have to worry about when you're doing your own problems. Okay, like I said, the problems have been selected specifically so that you don't have to worry about those kind of things. But there's a case where it does actually work out here. Okay, in fact, we have to worry about that. We have to use a supplementary angle. The original one does not work, but you won't have to worry about that. Okay. All right, so that's an example of a side angle side problem. Okay, let me now get you what we're going to be working on here today in class. Okay, so there's two sides to this, and I printed 2 pages per side, so that way it can save on space. So on paper, I should say. I guess that geometry teacher, Rohan, did get you, to learn some stuff then. The one that made him learn all the Greek alphabet too.
that's right.
Yeah,
Do you understand? You understand the problem that we had with the original system?
Yeah.
So that's. So, and I'll explain it, but you won't need to work. But it's not too terrible. The basic idea is that ratio, we can sine inverse of that ratio there. That ratio, it's possible both in the first quadrant and the second quadrant. Okay? And so then we have to come up, so we could potentially then, when we do sine inverse, really get 2 angles. The first quadrant angle, which calculus gives us, but then also the supplement in the second sheet there. Okay? And so in fact, that's the one we want here to make this triangle actually, work out. You won't need to worry about that, no, for the test. Nope. All right. Whoops, sorry, I need to give you one. Okay, so we're going to look at this fishing boat problem first. And then I'll let you guys try the ship D to Lighthouse Rock problem later, okay? So we're going to do this one first, okay? And the reason why I like to go over this particular problem here is because it's a little bit funky with the whole orientation thing, okay? The bearing problem, I guess I'll call it. And also because it is a very popular problem on the benchmark, okay? And so I want to make sure that we kind of cover this idea of bearings and things because most of you guys aren't navigating on ships, right? Or maps or anything like that. That's what we use GPS for now, right? But just in case.
We live in a harbor. Everyone does in Maryland.
Exactly. So maybe in Annapolis all the kids know how to do this. But anyway, or Baltimore. But this is what we're going to be, we're going to talk about this one right here because, again, it just shows, it tends to show up on the benchmark, and so I want to make sure you're ready for that too. Of course, in preparation for our benchmark, we will have 2 practice benchmarks that we do, just like you do for every other class, and those 2 practice benchmarks are very similar to the actual benchmark, so there shouldn't be any surprises. Okay, and I took this from one of the practice benchmarks. Okay, so you'll see this one exactly again. Okay, but you'll probably have forgotten it by that point because it'll be the new year. Okay, new year, new you, right? All right. So let's read through this here, okay, and we'll see our setup. So a fishing boat is heading due south, okay, and it's about to turn towards one of two docks, okay. Dock 1 is located at a bearing of south 55 degrees west of the boat, okay. So there's two measurements, or sorry, two directions, right? We have south and then west, and the idea is the south tells us where the kind of initial side of our angle is, and then 55 degrees west tells us the direction the angle opens and in what direction the angle opens, right? So if a boat is heading due south, that means we probably want to draw our boat when we're drawing a picture, draw a diagram. And I'm going to probably draw the diagram over here just for more space, okay? Where should we put the boat? If the boat is heading due south, where should we probably put the boat in our picture? In the top, right? Because it's heading south, so we want to leave some space because it's heading in the southerly direction, right? So we'll draw a little boat. Okay, there's our boat, or there's my boat. You can draw your boat however you like, I guess. You can just put the word boat if you want to, okay? That's fine.
All the assumptions you need. My boat is a dodecahedron.
Okay, perfect. So, Dock 1 is located at a bearing south, so we're going to imagine we're facing south here, right? So we're going to call that just down in our problem here. Does it have to be that way? No, but we'll just pretend that it's oriented that way. Okay, so south, that's going to be the starting side of our angle, and then we will go 55 degrees west, okay? And so west in this case is going to the left, right? So it'll be something, so here's south. Right, there's exactly south, and we're going to go 55 degrees west, so like this direction. I'll put the 55 degrees right in there. Okay, like that. So south, but then rotate 55 degrees to the west, which is left for our purposes. Okay. But if you're on the boat, it actually would be turning right. But from where we're oriented, we're turning left. Right. So, south 55 degrees west. And that is a dock 1. So we'll just put, I don't know, like little, here's some like little piers, and there's like there's the dock 1. Oh gosh, that looks like nothing. But oh well, there it is, dock 1. Okay, looks like tally marks or something like that. It's not very good dock. Okay, dock 1, yeah, that's a dock. Those are Z's. Right, no, that's a dock. All right. Then dock 2 is located 10 kilometers due east. Due east means it's exactly to the right, exactly right. So exactly, not up or down at all. So horizontally, from dock 1 is dock 2 here. And I'll draw an equally crappy dock 2. So dock 1 won't be jealous. Okay, there's dock 2. And that's 10 kilometers, so you can go, we'll just go ahead and finish off the bottom piece there.
Wait, how did you know it was going to be that long?
Say again, sorry?
How did you know it was going to be that long?
How do you know it's going to be that long? That is a good question. Well, I'm looking at the part after dock 1 here. It says the dock has a bearing south 32 degrees east of the boat. So the bearing, so again, here's south of the boat, and then 32 degrees east, we'd have to go to the right there. Yes, good question, Jenna. The real reason why I do that is because I've done this problem several times before. But we do have justification in knowing that from the from the bearing there. So good question. Mr. Wood should not assume. So anyway, then we will connect the boat back to that dock 2, and the angle from south 32 degrees east there. Right. Ooh, you really can't read that with the way I drew it. I'm going to put it down here. Okay, like that. I see what you're saying. I'm doing it. I see what you're saying, but yeah, I think this is okay. I see what you're saying, though. That's more for like congruence, but anyway. So there's our diagram, okay, and that would get us 1 point. Okay, right there. So first question that we're being asked is which dock then, and I think we've got everything labeled, right? Dock 1, bearing. Dock 2, 10 kilometers due east of dock 1, bearing. Okay, yeah, so all that information is there. And we're asked in letter B then, which dock is the boat closer to? How much closer is the boat to this dock than to the further dock?
I think it's dock 2.
So, okay, but we want to find out precisely, right? So,
But also, we don't know how far up or down the boat is.
you're right, we don't. So, what are some shapes that we have here? Well, we have this triangle right here, this big triangle right here, okay? And we know some information about it. For example, we know that this side right here is 10 kilometers.
Yeah.
We know that this full angle right here is 87 degrees, okay? But that's not quite enough to figure out information here or here, right?
Yeah, we only have 2 things. We need 3.
Yeah. Well, let's see here. What else do we know? Well, we have, what other kind of shapes do we have in this diagram? Right triangles. How do you know they're right?
Because they're due, the boat is heading to...
The bearing is due south, so there's our due south right there. And then what is this right here? It's east-west, right? Because dock 1 is going directly east from dock 1, we find dock 2. So we have a right angle here and a right angle here as well. Okay. Maybe I'll start using a different color here to differentiate between what we were given and what we are going to calculate. Okay, so how is that helpful then? What can we use that to help us find? Find these third angles, right? So in the smaller triangle here, we can do, 180 minus 90 minus 32, or just 90 minus 32 if you like.
The bottom line is 5. It's in half.
That's not necessarily true, okay? So that's a good point, though. I do want to talk about that.
And how do you...
Does our north-south line cut dock 1 this distance here in half?
No, because the
It
angle
can't. Exactly, because these two triangles are not going to be congruent, probably, right? And so then those sides won't be the same, okay?
Okay.
So we can still solve this, though, believe it or not, right? So 58 degrees is the angle there. All right, because again, just 90 minus 30, or 180 minus 90 minus 32 gets you that. And then 180 minus 90 minus 55, okay, so will get us the other angle there. Okay, so 35 degrees. Okay, like that.
It was 180 minus 90 minus.
So we have the two triangles here, right? So we've got this triangle right here, this little right triangle. And so just do 180 minus that 90 minus that 32 to get the missing angle there. And then same thing for this right triangle right here. 180 minus 90 minus 55 to get you the 35 degree angle there. Now, armed with that knowledge, do we have enough now to solve for the distance to dock 1 or the distance to dock 2? We do, right? Because now we have our angle right here, right? That's an 87 degree angle there. Okay. And we have an opposite side, bless you, pair, right? And so now we can use, what should we use here then? Law of sines, right? Law of sines, okay? So we're going to have to set up two law of sines. And yeah, we can just call this, let's see here. Did I try and come up with a clever way of naming these things? I don't think I did. I just called them X and Y. You can call these sides whatever you want there, okay? I'll just say X and Y. You can use whatever side lengths you want there, okay? And so we get then sine of 35 over X. And we also have to do then sine of 87 equals sine of 58 degrees over Y. Okay. Do be careful that you label and then associate the correct distances and stuff like that. So, my y is opposite the 58, so I do sine of 58 over y, right, for the law of sines. My x here, right, is opposite the 35, so I do sine of 35 over x, right? It's always angle and opposite side, or side and opposite angle, however you want to pair it up there. Okay.
And the unit is going to be in kilometers.
Right. Whoops. Okay, so there's our setups. We can then, that's our precise answers. Of course, we'll throw them into our calculator to get the decimals. Yes.
For the benchmarks,
Mhm.
like for the work problems, do we have to like show all their work? Because I remember on Mr. Thompson's, like we were just wrote sentences with the right answer and he gave like all the points for them.
I will be okay with that. How? Ooh.
Because it frankly saves time. Like, is it 42?
I see what you're saying. We will, when we go over the benchmark, I will show you the scoring guidelines, and so you will see which problems require what kind of work and stuff like that.
Yeah.
Justification or something like that.
Because
I understand what you're saying because you're worried about like time, the time,
not really
limit.
just that, it's because on Mr. Thompson's benchmark,
Uh huh.
I didn't really show much work, but I still got like all the points. And
Okay.
then
I got you.
Idris.
Showed all the work, but messed up.
Yeah.
Yeah. So I mean, we'll see. But like I said, I'm going to obey whatever the scoring guidelines say. So the scoring guidelines require work, then you got to show some work, kind of thing,
Yeah.
whatever it requires. If it says just answer, kind of thing, then okay, I'm fine with that too. So yes, Jen.
For text, we both got 5.744, and we don't know.
That's what I got.
Yeah.
Yeah, I was reading and then I
Where it's like, wait a minute, how are we
problem
gonna do this?
solved. So
Okay.
okay, so congratulations, you're going to college.
Oh, I already got accepted in University of South Carolina.
Oh,
But
okay.
Texas Tech is my second school.
Okay, good.
And that one's like really hard to get into.
Cool. So, right. So, are we done here? Did we answer the question that was being asked?
No.
What do we still have to do?
Which one's close? Which one's the least amount of distance?
Oh, so right. So the answer here would be doc what? Doc 2. Okay? And again, it's helpful. Maybe you should, write up here, okay, that's like about 5.744 there.
And then you
Okay? And that's about 8.492, okay? Again, I would recommend because, just watch where these lengths go, right? 5.744 is this length, right? So you want to say then doc 2 is closer, but we have to figure out by how much, right? So what do we do to find out how much closer? Yep, subtract. So 8.492 minus 5.744 equals 2.748. Okay, so doc 2 is closer by 2.748 kilometers. Okay? Doc 2 is closer by 2.748 kilometers.
Go pee.
Okay. Questions on any of that? All good so far? All right, last one then. Part C, a dock worker spots a swimmer in danger, hanging onto a buoy that is 3 kilometers away from dock 2. Okay? I don't know, if you're hanging onto a buoy, Anyway, the buoy has a bearing north 18 degrees east from the dock. How far would the fishing boat have to travel to rescue the swimmer? So, I hope I can add this onto my picture here. I think I have enough space to do this.
Yeah, I see one that does. Yeah. Oh yeah, Big Shark. Yeah. Ever seen that movie?
The one with Blake Lively or whatever?
Yeah, Shadows.
I did not see it.
It's good. Oh my god.
Was
It's
it
a
good?
good movie, but it's just like.
My mom thought it was so
No, I know it's on Netflix.
She was so scared. No, I'll take me laying down.
So, the buoy has a bearing north 18 degrees east from the dock, from dock 2. So we're at dock 2. This is where our observer is, right? And they spot the person. And again, it's a bearing north 18 degrees east. So imagine, okay, here's like north. Right, here's north. And then 18 degrees east, it's going to go out, this direction somewhere. And we'll say that's about 18 degrees right there. Okay? And so we'll say there is the swimmer on the buoy. Okay, I don't know, buoys kind of look like this maybe. Is it like one of these little dealies with the light on the top and like a little hat and goes, and it looks like little stripes. And there's like the little person hanging on. Okay, there they are. It's a buoy.
He looks like he's like doing it like water ski thing.
Probably. Why's it gotta be a he?
He's sitting in the buoy and he's just.
Because it's me. Because it's me. I can't swim. Just kidding, I can. Anyway, all right, so how far would the fishing boat have to travel? So now we're going to find this distance right here.
That's all you can do.
And we know, somehow we know that that buoy is 3 kilometers away. I guess it would be maybe known that, you know, how far away the buoy is. Yeah, right.
So when
I'm going to go up. I have to measure this distance, but I'm not going to rescue you. I just need to know the distance. We're going to send the fishing boat over to get you.
So would it be
So we're trying to find this distance right here. I'll call this distance Z maybe now.
east from the boat though?
We don't know, right? We don't know that, though. We don't know that. Okay, we do not know that. So what's the information? Well, we have a new triangle here now. Okay, we have this side of the triangle right here is 3 kilometers. Okay, we also know this side of the triangle here, 5.744. Okay, so we have this side of our new triangle as well. Okay, and we have this little piece right here. So what kind of like information does it look like we're setting up for here? We have a side, and we have like this little part of the angle. So it looks like we're maybe going to do a side angle and a side here.
Wait, no. Because it's not. Okay, so what's the not reciprocal? The other half of 58. If
The
you're gonna do
complement
90.
is what you were looking for, I think there. Yes. So the complement would be whatever you add with 58 to make 90. So 32 degrees there.
32? Wait. Oh yeah.
So this little piece right here is 32
Then
degrees, and so we know the whole angle then, okay, is going to be 50 degrees. So the whole thing here is 50 degrees. Okay. So with this information, then we're going to use law of cosine. You have to use law of cosines now because we don't have an angle and opposite side pair that we know. Okay. We have the side, but not the opposite angle. We have the side, but not the opposite angle. We have the angle, but not the opposite side.
well, we can get the angle. Wait. What's the thing of 32?
True, but we don't know this is east-west, so we can't say.
Oh, right.
No, we don't know if it's parallel or not.
It's not
Yeah,
the right angle.
we don't know that. So good thinking, but yeah, unfortunately, this is the way we got to go.
Why did you draw
So,
the icon?
law of cosines here. Okay, law of cosines. We got our angle and our two sides, and so we can kind of use whichever formulation we want here. We want to use the formulation though where we have this angle in it. So, I don't know how I want to do this here, but basically it's going to be we're solving for that missing side. So I'm going to say just z squared equals, and then we'll put the 5.744 squared plus the 3 squared minus 2, that's a 7, times 5.744 times 3 cosine of 50, we said, right? Yes. Okay, and so there's our 7. Okay. And so z will be just the square root of that mess. Okay, like so. So we'll type that in my calculator. I'm just going to do the whole thing at once. Because why not? Oop. There was an attempt. And the whole thing goes underneath the square root. And I get approximately 4.454 kilometers.
And then we can get the angle by doing law of sines.
So it's not necessary now. All we wanted
right.
was just that distance, and we found it. So we're actually done. Okay, so the distance to the swimmer is 4.454 kilometers from the boat. From the boat. Good. Yeah, it's if you can type it all in your calculator, it's helpful, and you don't have to worry about all the little steps and stuff. Okay.
Oh, good.
Questions on any of that? All right.
Just going to watch
Just gonna watch video. Oh, and I can help too. So what I'm going to do at this point then, if you want to flip the paper over, there's more practice word problem. That one doesn't have any bearings, but it does still have like law of sines, law of cosines practice. So if you want to get some of that practice in there with like a word problem, you can. Alternatively, I also have some homework here for you. Page 441, numbers 7, 9, 19, 31, 47, and 52. And these are again all calculator active. Okay? So your choice, but I'd say, you know, one or the other here, right? So either work on the book problems or try that word problem with that. I have the answer key up here too, so if you want to come and like take a look at what the answers are for the problem in the back.
Are you gonna go over it Monday?
Yeah, we can do that. We can go over it Monday. Yeah, yeah.
Is what we're learning on Monday on the quiz, or is it just?
No, no.
what's today?
So this concludes our look at law of sines, law of cosines. The quiz will cover anything we just covered then,
So
basically.
we could do this and then the homework, go over it Wednesday, and then we could take the quiz Tuesday if we wanted to.
If you want to, or Monday in class. Or Monday it said if you want to. It's too much of a turnaround.
No, because then you can go home and study.
True.
Mr. Rebecca, I have an unrelated question.
Unrelated
How
question.
do we find our scores for the PSAT? Will it be an email?
They are going to be delivered, I think, soonish.
Yeah, it's next week.
Okay, I
Like,
think
do we get like a
you might
piece
get
of
a paper. I think you get like a paper
They're
or
on
like your
all
little
boards.
booklet. I think.
What is the distance